Saxon, oh, I squeaked. Saxon Algebra 1/2, Lesson 117. Kayla, welcome to the last week of new lessons. 117, 118 today, and then 119 and 120 next time. We're done. That's as far as we're going. Time for the final. And then it's summer. Yay. Lesson 117 is one that we're going to come back to next year. And we're going to use it a whole lot. It's called the Pythagorean theorem. You may have seen it before. It comes up again and again. It's technically a geometry concept, but it is very useful. But you have to know, you have to have some algebra to know how to solve for it. So it's algebra and geometry combined. First, I want to tell you that Pythagoras, the dude for whom this theorem is attributed, he was a Greek mathematician. He was born on a Greek island called Samos. I think it's cool to understand the history of mathematics just a little bit. We don't have to kill it. In the 6th century BC, so a long time ago, he lived in Italy then in a town called Crotona, but his name was Pythagoras, okay? And he came up with the idea that we're going to talk about. I'm just going to jump in. What he determined was that if you have a right triangle, he determined this works for all right triangles. And remember, by right, I mean that one corner is a right angle. Okay? His theorem only works on right triangles. That's something that often gets lost in the details of explaining how this works. When we have a right triangle, we can call the straight sides, if you will, the legs, and this one is the hypotenuse. Hypotenuse is a fancy name. It's the one, I think it means something like down under or something like that. It's a reference to the location, but it's the one opposite the right angle. That's how you can tell where it is. I mean, it's pretty easy to tell by looking at it. I always think that right angles look like you took a piece of paper and then cut the diagonal. So it's the diagonal, it's the cut side. I'll often refer to it that way. Okay, so here's what our buddy Pythagoras figured out. He figured out that, first of all, it's super helpful if you label these sides. The legs are A and B. It doesn't matter which one is A and which one is B, but the hypotenuse always has to be C in order for this to work. He figured out that if you take the length of side A and square it, and add it to the length of side B squared, those two will total the hypotenuse squared. That's the Pythagorean theorem. Okay? Which is cool because what it means is that if we have any two of these three lengths, we can figure out the third by using this formula. And that's where the algebra comes in, because we have to learn how to solve that. Okay, so that's a really cool thing. John in the book shows you a bunch of pictures. I'm just going to show you. He shows you a bunch of pictures that are meant to help you understand why this theorem works the way it does. I say this can be just extra confusing. So sometimes the picture of this doesn't help you understand what exactly the Pythagorean theorem, it just muddies the water is what I'm trying to say. So I like to say, let's just focus in on the numbers and see how they behave. And then in time, we can talk more about the why. But right now is not the time. Let's just dig in and do some problems. See how the numbers behave. Okay, here's a triangle. Bum, bada, bum. Now, one of the things that can be slightly confusing about this whole Pythagorean theorem business is that we can draw right triangles in lots of different ways. That's okay, don't let it worry you if it changes. All you have to do is orient yourself Where's the right angle and where's the hypotenuse? Oh yeah, they're always opposite, right? That means this is the C, and we'll call this one the A since it already is, and we'll call this one the B. All right, you can name them anything you want as long as the hypotenuse is the C. So I guess you can't really name them anything you want. Call me a liar. I don't know. You see what I'm saying. So now we're gonna use this, and we're gonna plug these numbers in. So A squared, that's the mystery, plus 4 squared equals 5 squared. Make sense? Okay. Now we're going to just do all the squarings that we can. A squared plus 16 equals 25. Oh, I'm feeling so much better, aren't you? Now we're going to subtract 16 from both sides. We get a squared equals 9. Now, the way that we solve this is new. We haven't done this before, but when we're squaring a variable and we want just the plain variable, we do the opposite, which is taking the square root. Make sense? These two counteract each other. Squaring and taking the square root are like adding and subtracting or multiplying and dividing, where they're opposite functions. So this comes out to just a nice plain A. And over here, we get, okay, the square root of 9, we know what that is, it's 3. Now, we also have to say it's plus or minus 3, right? Because positive 3 times positive 3 equals 9. But negative 3 times negative 3 also equals 9. So negative 3 could be a solution, right? So in terms of algebra, we have to recognize that minus 3 is a solution. But we're not working in just pure algebra. We're working in the world of geometry. Do you think there's any possibility that the length of this side could be negative 3? Yeah, I agree. It's not possible. So for purposes of geometry, we can simplify our answer to simply A equals 3. All right, we don't have to take that negative root into account because there's no way that could be a negative side, a negative length. All right, okay, 2 more. Whoops. Example 117.4. And this is what I meant when I said that sometimes these triangles get a little wacky. John floats this one. It's hovering in the air. 4, 5, and P. Okay, so the first step is to figure out which are the legs and which is the hypotenuse. The hypotenuse is always opposite the right angle. So this is the one that has to be equal to C. And then we can call these A or B, whichever we want. It doesn't matter because remember, in our formula, this is why it doesn't matter. These have to be the 2 legs. Sorry, I wrote hypotenuse. Those have to be the 2 legs. And we're going to add them together. Order doesn't matter. So if I call this one A or B or this one A or B, it doesn't matter as long as I get each of them in there. This is the hypotenuse. It has to be the hypotenuse. Okay, so here we go. We're going to say that 4 squared plus 5 squared equals, and I'll just leave it P squared. It doesn't matter which letter you use, whatever seems least confusing to you. 4 squared is 16, 5 squared is 25. I add them together. Now I want to get just the single version, so I take the square root. Now I'm going to, I'll just leave it like this. So there isn't an easy answer for that, so I'm just going to say positive or negative square root of 41 equals P. But I know it can't be the negative, so I just say P equals the square root of 41. That's my answer to this geometry problem. And guess what? Yay, it's right. Okay. So this was a good example of a problem where we had both of the legs and we were solving for the hypotenuse. And then this last one we're going to do is where we're missing one of the legs. There aren't 3 versions of this problem. It's either you're missing the hypotenuse or you're missing one of the legs, which is this one. Right? Okay, There's the right angle. There's the side opposite. That has to be the hypotenuse. This time, let's call this one A and this one B. Okay? So I'm going to plug in, let's see, this is A, so I'm going to say m squared plus 7 squared equals 9 squared. And then I can say m squared plus 49 equals 81. I subtract 49 from both sides. M squared equals, let's see, this would be 32. And then I take the square root of both sides. M equals, and I'm going to skip the step of showing the positive negative. I know it's geometry, so I know it has to be the positive square root, like so. Okay? That's our final answer. And I'll just show you what John did in the beginning of this lesson was he let us practice this square root process just a little bit. That's why we didn't do the first example. I just threw it in for you. I guess there's actually 2 of them. P squared equals 16. Take the square root of both sides. We say P equals plus or minus 4. That's an algebra answer because this is an algebra problem. In geometry, we would eliminate the negative root as a possible answer because the length of a triangle is not going to be -4. But for algebra purposes, we can leave it in. And then the other example that we skipped over is P squared equals 42. Again, we take the square root of both sides and we get P equals, and in this case, we want the plus and minuses because it's just an algebra problem, but 42, square root of 42, we can't simplify. So we just leave it like that. And those are the right answers. Okay. Section C of this lesson, I don't want you to look at. What John is doing, again, kind of like what he was doing here, where he's trying to help explain the theory and why the Pythagorean theorem is true. That's what he's doing here. It's called a proof or a demonstration. But he draws this complex diagram and then he walks us through this complicated process that proves that a squared plus b squared really does equal c squared. We will get to this in advanced algebra. It's nothing you need to worry about now. Just focus on a squared plus b squared equals c squared, plugging in the numbers, solving it, eliminating the negative root, blah, blah, blah. Don't worry about this whole demonstration business. Okay, that is our lesson 117. Goodbye.